Databases are the workhorses of business data management. They are used to collect, store, and manage transaction data like sales transactions, as well as analyze large volumes of data like those found in data warehouses. It is safe to say the bulk of data used in businesses and other organizations is stored in relational databases. This makes relational databases an important source for data scientists. Now, relational databases are more than just a storehouse for data. They are data management systems that can be used to perform common transformation and analysis operations. Relational databases link data across data stores, filter and reformat data depending on how it needs to be used, aggregate data to provide kind of a big picture summary, as well as answer specific questions about business operations. Let's consider what goes into a production data science environment. To start, we have data sources that can include relational and non-relational databases, often called NoSQL databases. We will refer to both as data stores. Applications and web logs are another source of data for analysis. These are typically less structured than relational data, and they may require significant filtering, formatting, and data extraction operations. Also, small, manually curated data sets that may be maintained in a spreadsheet are often used as a data source. As one can see, data scientists might need data from multiple sources. In these cases, a common practice is to collect data into a single repository prior to analysis. The process for extracting, transforming, and loading data into a data warehouse is called ETL. As the first step of the ETL process, an analyst extracts data from a transaction processing database, an application log, and a personally managed spreadsheet, and then stores all of that in a relational database. If it's a really large amount of data, the data scientist may use a big data platform such as Hadoop. The second ETL step, transformation, is a sequence of operations performed on data to make the data more suitable for analysis. Data scientists often need to reformat dates, replace missing values with zeros, and strip out trailing blanks from strings. Some analyses, like building machine learning models, can require additional transformations, such as changing the scale of numeric values or using even more involved calculations to estimate missing values. Finally, loading is an ETL process step that occurs when data is moved into a data store for analysis. This may sound simple, but large data sets can require specialized techniques, like parallel data loads, to ensure that the data is loaded in a reasonable period of time. Analysis and modeling tools are used by data scientists for a range of activities, like identifying useful information, building predictive models, detecting anomalies, and to make any recommendations. These tools read data from data stores and may write results back to databases as well. Relational databases play key roles throughout the data science process, which ultimately leads to valuable insights into business problems.